Good morning. Today we are going to discuss one case study. So our topic is Fourier series. First let's see the definition. What is meant by Fourier series? It is a combination of sine and cosine series. So empathy part, Nishita, start your empathy part.
Good morning everyone. Today I am going to explain about the empathize part. In the empathize part, we actually need to understand the problems and needs of the users. Who are the users? The students learning mathematics and the engineers analyzing the electrical circuits and the scientists studying waves, vibration and heat flow and the image and video processing developers. And what is the problem? They frequently deal with the problems in periodic functions. What are periodic functions? The functions are treated at regular intervals. For example, sound waves, music and speech, and electrical waves like AC voltage and current, and the vibrations in mechanical structures and the heat distribution in broad. Handling these periodic signals directly is very difficult when the function is not smooth, like a square wave or sawtooth wave. What are the needs? The need is to build a universal mathematical tool that can break down these complex periodic signals into simpler and standard blocks so that they can be studied and manipulated and transmitted more easily.
Now we clearly define the problem statement. How can we represent any periodic signal in terms of simpler, well understood function? Irregular periodic signals are very hard to compute and analyze. Polynomial approximations is not always useful for any periodic signal since polynomials do not repeat naturally. Engineering systems require precision, can need a way of exact frequency information.
For this problem, there are multiple solutions to consider. First is polynomial representation. In this representation, we can use Taylor series to approximate the functions. Since it is well worked for analytical functions and does not handle periodicity well. And second is piecewise approximation. It is used to approximate the analytical functions and periodic functions. Since it is simple and it can be used for complex waves. And third is trigonometric representation. Since trigonometric functions are considered naturally as periodic functions, they can be combined to approximate the periodic functions. The best solution to approach Fourier series is to combine periodic functions as a sum of sines and cosines of different frequencies.
So good morning to all. So now we see about what is Fourier series, about empathy, define and ideate. So my topic is about prototype. So building examples for this prototype are three types and three waves: square wave, sawtooth wave and triangular wave. So these square wave represent as a sum of odd harmonic function, and sawtooth wave represented using negative and positive harmonics, and the third wave was triangular wave, which is represented using cosine functions for the harmonics. So as we add using more terms, the accuracy will be increased. So for that, the accuracy, and so for getting this accuracy, the result of this Fourier series will be stable and more accurate. So thank you.
Testing. Engineering application, electrical engineering, mechanical engineering and heat transfer, electrical engineering, analyzing AC signal harmonic in power systems, and mechanical engineering, study the vibrational using string beats and structures, and in heat transfer, solve the heat equation in rods and plates using Fourier series. Applications of the Fourier series: signal processing, electrical engineering, mechanical engineering, heat transfer, image processing, communication system, acoustics and quantum mechanics. In communication system, it is used in the modulation and demodulations of the signals, and signal processing is nothing but it is used to break down the complex signals, and acoustics is signals in musical tones and sound vibrations, and electrical signals is analyzing the AC signals in a non-sinusoidal way, and in mechanical signals it represents the vibrations of the steels and structures, and in heat transfer it represents the heat equations in the rods and the plates in the Fourier series.
So we all came across this situation, like we will open the textbook when we saw the equations with infinite sums of sine and cosine. We think what is this and how it will help me in the future. But as scientists and engineers, we definitely apply in our future. Yes, of course, Fourier series is difficult to visualize and connect, but
Final part, I am going to conclude what is Fourier series. So Fourier series is a periodic function that break down into simple and basic cosine and sine wave. So it makes easy to study complex signals by breaking down into many components and make the signal to strengthen and to learn quick. So it is used in many fields like signal frequencies and sound analysis and transformers inclusions. So these are my finals and conclusion part. So thank you all.